Hello everyone, this is Y. Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today, in this session, I am going to discuss about the concept of transaction management. Transaction management. So, what is meant by transaction and how we are managing the transactions in the database management system? Today we are going to see. So, first of all, what is meant by transaction? So, definition of transaction. In generally, we are having a different types of transactions, banking transactions, financial transactions, and everywhere financial transactions, everything we are going to do some transactions. So, but apart from that all, what is meant by transaction actually? So, a transaction is a set of operations used to perform a logical set of work. So, we are going to do some certain operations to complete one work. That work is nothing but logical set of work. Logical set of work. So to complete that work, to do that work, we have performed some set of operations. We have performed some set of operations. So transaction is nothing but a sequence of operations or a set of operations to complete that work actually. To complete that work. So a transaction usually means that the data in the database has been changed. The data in the data has been changed. So a transaction usually means that the data in the database has been changed. So every time we are doing some certain operations, automatically related to that operations, the transactions were changed. The work sets are changed. So that one of the major uses of DBMS is to protect the user's data from system failures. So we are going to perform a different types of operations on the database actually. But all the operations may not execute perfectly or may not store permanently, or maybe some operations are failure due to the system crashes or some systematic errors. So for that purpose, for recover purpose, for we are rollback purpose, we have to do this all the transactions actually. So the one of the major use of DBMS is to protect the user's data from system failures. So system failures, we are going to recover the data or roll back the data or keep providing security of the data. So executing the same program multiple times will generate multiple transactions. So executing the same program multiple times will generate a multiple transactions. So a transaction is nothing but a set of logical set of works. Logical set of works contains different types of operations. So example, we can see a transaction is to be performed to withdraw cash from an ATM. So generally, withdrawal from the ATM is one transaction. Deposit account into account holder is one transaction. Checking the mini statement or checking the balance of the account holder is one transaction. So to do that all the transactions, to complete that all the transaction, we have to do some set of operations. We have to do some set of operations. So consider the following example for operations, the transaction operations as follows. So ATM transaction steps. So when we are go to the ATM center, we are going to withdraw some amount and deposit some amount or checking the balance account or change the pin, and so these type of transactions we are going to do at the ATM centers. So among that all the transactions, we are taking one transaction. So withdrawal amount. So for that withdrawal amount, the withdrawal amount is one transaction, but to complete the transaction, we have to perform some set of operations. We have to perform some set of operations. So that operations are what? So first of all, transaction start. So insert your ATM card into the ATM machine. Select a language for your transaction and select the account option, whether it is saving account or current account. Select the saving account option. Enter the amount you want to withdraw. Enter the amount you want to withdraw. Or enter your secret PIN. Wait for some time for processing. It is displaying the message to wait for some time to collect the cash. So after that, collect your cash and collect your card. After that, it is asking you to display the amount, and if you want to continue or more or not. It is asking you to click or press yes or no. After that, the transaction is completed. After that, transaction is completed. So to withdraw amount from the ATM, these are the steps to complete the transaction. So that is the transaction start. Insert ATM card, select the language for transaction, select the account option, enter the amount, how much amount you want to withdraw, enter your secret pin, and wait for processing and collect the cash. After that, collect your card until the transaction is completed. So to do this all the transaction operations, we have to perform these operations. One is read the data or access the data. So read or access the data, and write or change the data. So write or change the data, and then commit the transaction. So any of the transaction is performing all these three operations. Any of the transaction you are performing is with these operations. One is read or access data, second one is write or change the data, and third one is commit option. So these are the three operations. So we'll take one example. So transfer of 50 rupees from account A to account B. So here in this example, we are going to take the account holder A and account holder B. These two are the users, account holders. Here we are going to transfer 50 rupees from A account to B account. We are going to transfer 50 rupees from A account to B account. But initially A account holder having 500. When you transfer this 50 rupees to B account holder, now B account holder is having B equals to 800. Whenever you can transfer the 50 rupees amount from A account holder to B account holder, automatically what will happen? So first of all, the read operation is performed, that is how much amount the A account holder have. So that is accessed from RAM itself, that is accessed from main memory itself. The how much amount is stored in the transaction that account holder consists of 500 rupees is from RAM. When you are performing debit 50 rupees or transfer 50 rupees to B account holder, automatically that 50 rupees is deducted from A account holder. So after transferring or after deducting that 50 rupees to B account holder, automatically the write operation is performed, that is nothing but update operation is performed to update the balance in A account holder. That is write of A equals to 50 rupees is deducted, right? So 450. So updated balance is what? 450. So before doing this, what is the value of B account holder? Read of B equals to 800. After performing transaction, 50 rupees is added here. So the updated balance of B account holder is what? 850 rupees. So this is updated in the RAM itself. So after updating these two, it is asking you to perform any more transactions. If yes, then it is permittable to do the transactions. If no, the transaction is committed and asking you to leave the ATM machine. So this is the way we can perform the transaction. at different stages with the help of these operations: read operation, write operation, read or access. We can say that, write or update. We can say that, and the commit operation. So these three operations we can perform at any transaction point of view. So what are the uses of transaction management actually? So the DBMS is used to schedule the access of data concurrently. So every time we are doing some updates from the database, automatically accessing the data is concurrently updated. So it means that the user can access multiple data from database without being interfered with each other. So that means one transaction is not depending on another transaction, or one transaction is not disturbing with another transaction. So they are all individual transactions. The transactions are used to manage concurrency. So it is also used to satisfy acid properties. It is also used to satisfy acid properties. So acid properties are what? Atomicity property, consistency property, isolation property, and durability property. Durability property. So these are all acid properties, and it is also used to solve read or write conflicts. Read or write conflicts. So read or write problems from the transactions also we can able to solve it. And it is used to implement recoverability. So if any losses or failures will occur in the transactions or during the transactions, we can implement the recoverability concept. And also serializability, scheduling the transaction serially or non-serially, and the cascading rollbacks also, and cascading rollbacks also. So this is all we can use for rollbacking the transactions, or recovering the transactions, or restoring the transactions also. So transaction management is also used for concurrency control protocols and the locking of data. So this transaction management is used to concurrency control protocols. That means they are going to lock the transactions to do not occur some deadlock situations or some other difficult situations. So to avoid that all the things, we have used this transaction management. So limitations of using transaction management. So it is somewhat difficult to change the information within the transaction database by end users. So every time we are updating the database is also somewhat difficult, because the database updating is always to keep track of the data. So that is what somewhat difficult to change the information, and we need to always roll back and start from the beginning rather than continue from the previous state. So whenever you want to perform a rollback or restoring operation, always you are starting to perform from starting onwards. You have to perform from starting onwards. It is not possible to roll back from the previous state. It is not possible to roll back from previous state. So these are all some uses of transaction management. And the next one, transaction states. So whenever you are performing transaction from starting to ending of the transactions, automatically some stages will occur. Automatically some stages or states will occur. So in the like operating system, the process states diagram. So as like we started in the process state diagram also. So transaction states. So states are nothing but stages that your transaction is passing through all the stages. The transaction is started from one side and it is ended to the another side. During that starting and ending of the transaction, it crosses all the stages. It crosses all the stages or states. So the states through which a transaction goes during its lifetime. The states through which a transaction goes during its lifetime is called as all the states, is called as the transaction states. The following states which tell about the current state of the transaction and also tell how we will further do the processing in the transactions. So the transaction states will decide that the current situation or current state of the transaction, and the next future desired state also it is going to display. So that means the transaction is going to store the information about the current situation or current state, or it is going to show that the next situation or future situation of the transaction also. So these states govern the rules which decide the fate of the transaction, whether it will commit or abort. So it follows some rules and ethical principles to complete the transaction. So in which state the transaction is happening, and in which state the transaction is failure, in which state the transaction is completed, always the states are going to describe the transaction behavior. The transaction behavior. So we will see here, this is one active state, partially committed state, and committed state, and a terminated state, and aborted state, and a failed state. So from the transaction beginning, from the transaction beginning to transaction end, the two types of behavioral it presents. One is success behavior and the second one is failure behavior. In the success behavior, it is also performing read or write operations of the transaction. So once it is read or write, the next stage is a partially committed state. Once it is partially committed, it is going to store permanently in the database. So that means committed state. Once it is committed, the transaction is completed. That is nothing but terminated. The transaction is completed or the transaction is terminated from the transaction management. Transaction is terminated from the transaction management. That is a success transactions. A success transaction. But in the failures transactions, whenever it is started from the starting state, active state, the transaction is failure because of some reasons like system crashes or logical failures or disk failures or system failures, anything. So in that case, it is failed state. So that failed state will enter into the aborted state, that is going to abort the situation or terminate the situation. So once it is aborted, it is not able to roll back or not. If it is rollback state, then it is rollback. The transaction is become rollback. If it is not rollback state, then it is going to be terminated state. So the transaction which is in aborted state is going to be rollback, but the situation is not there, then it is going to be terminated. So the transaction which is rollback in the aborted state is going to be rollback. So again it is going to perform some operations and it is committed. But if the transaction is not able to roll back, then the transaction is going to be aborted and it is terminated. It is terminated. So this all the diagram is looks like a process state diagram in the operating system. In the process state diagram, we can see all the processes running from new state to terminate state last. So the new state, ready state, running state, abort state and terminated state. So all the processes are crossing all the stages to complete their process. So in the same way, the transaction states also, to complete the transaction from starting state to ending state, all these stages were crossing. So one is for successful operation and second one is for failure operation. So for the successful operation, the active state and partially committed state, the next committed state and the next terminated state. But in the failure case, active state becomes a failed state to aborted state to terminated state. But in the case of rollback transaction, the transaction has become ineligible to rollback, then it becomes rollback again. Right? So this is the way you can understand the transaction state. So here you can see the first one is active state. So active state is the first state of every transaction, and in this state the transaction is being executed. In this transaction, the transaction is being executed, that is ready to execute the transaction. For example, insertion or deletion or updating a record is done here, but all the records are still not saved to the database. So the transaction is done here actually. Insertion operation is done, deletion operation is done, updation operation is done, but all the records done with that operations are still not saved to the database, actually. So the next, partially committed. So in the partially committed state, a transaction executes its final operation. But the data is still not saved to the database. The final operation is over, but the database is still not committed because it is a partially committed. So in the total mark calculation example, the final display of the total marks step is executed in the state, but all these marks is finalized and it is not committed in the database. So those marks will be finalized, but they are not committed in the database. They are not committed to save in the database. And next one, committed. A transaction is said to be in a committed state if it executes all operations successfully. In this state, all the effects are now permanently saved on the database system. So all the operations are executed successfully. So now the database is also having committed state, so that database is saved permanently. And the failed state. So if any of the checks made by the database recovery system fails, if any checks made by the database recovery system fails, then the transaction is said to be in failed state. So due to system loss, due to system failures or disk failures, any failures, it becomes in failed state. So in the example of total mark calculation, if the database is not able to fire a query to fetch the marks, that means if any query is not fetched or executed, then the transaction is failed to execute. And aborted state. So if any one of the checks fail on the transaction has reached a failed state, then the database recovery system will make sure that the database is in its previous consistent state. If not, then it will abort or roll back the transaction to bring the database into a consistent state. So that means if any operation or if any transaction is failure and it is able to roll back, then it is having the eligibility to roll back the state, then transaction is going to be roll back again here. From aborted state is going to be roll back the transaction. So in this, if the transaction fails in the middle of the transaction, then before executing the transaction, all the executed transactions are rolled back to its consistent state. So all its previous transactions are to be rolled back to consistent state. So after aborting the transaction, the database recovery module will select one of the two operations. One is restart the operation or kill the operations. Once the transaction is entered into the failed state to aborted state, now the transaction is having eligibility to either restart the transaction or either kill the transaction. So it is able to roll back it or restart the transaction or else kill the transaction. Those two transactions are done when the transaction is in the state of aborted state. Right? So this is the way you can understand the transaction states or transaction state diagram. So transaction properties. So what are the transaction properties actually? So there are four main properties of transaction presented in the acronym of ACID. So that refers to atomicity, consistency, isolation and durability. The first one, atomicity property. So a transaction cannot be subdivided and can only be executed as a whole, and it is treated as an atomic unit. That is nothing but entire database is going to be taking as a single unit. That means it contains single values or single unit values. It is either all the operations are carried out or none are operation performed. So it is either all the operations are carried out or none are performed. So either performing all the operations or no operation is going to be performed. So that takes only single atomic operations or single atomic values. And second one, consistency. So after any transaction is carried out in a database, it should remain consistency. So after any transaction is completed into the database, it is committed into the database, then it should remain consistent and no transaction should affect the data residing in the database adversely. So no transaction should affect after the committing of the transaction, then no changes will occur in the database that will not happen to commit to the database. And third one, isolation. So when several transactions need to be conducted in a database at the same time, each transaction is treated as if it were a single transaction. As a result, the completion of single transaction should have no bearing on the completion of additional transaction. So the individual transactions, so one transaction is not able to depending upon another transaction. So the transactional disturbances will not affect another transaction. So one transaction disturbance is not going to affect on another transaction disturbance. So that isolation property satisfies. And the next one is durability. So from durable all changes made must be permanent. All changes made must be permanent. So such that once the transaction is committed, the effects of the transaction cannot be reversed. So once the transactions are committed, and that transaction will not going to be rolled back again. So in case of system failures or unexpected shutdown and changes made by a complete transaction are not returned to the disk during restart, the changes should be remembered and restored. So these are the transactional properties. We can say that transactional properties. And the transactional control commands in regular sectors, in the regular real time operations, the transactional control commands are performing for the different banking operations. So in these below are the transactional commands. The first one is what? Commit. The first one is what? Commit. So it saves the changes done against the database. So it saves the changes done against the database. So it contains whenever the transaction is committed, whenever the transaction is completed and it is committed, all the changes are saved permanently. All the changes are saved permanently. And rollback reads the changes done before being committed to the database. So before being committed to the database, whatever the changes you are going to make or whatever the changes you are going to apply, that changes you can apply by rollback the transaction. You can apply by rollback the transaction. And next one, save point. And next point, save point. It saves a point in a transaction on which to carry out a rollback. It saves a point in a transaction on which to carry out a rollback. So at certain point of time, at a certain point of block, so which point you are going to save for the rollback and which point you are going to roll back for the transaction is going to be saved here. So you can keep all the save points for the particular transaction so that you can roll back up to that transactions only, up to that save point only. So on the next one, set transaction. It gives a name to the transaction. It gives a name to the transaction, whether the particular transaction is for withdrawal cash, whether a particular transaction is for depositing cash. So that is the transaction you are going to set. And to do all these transactions, you can use some following syntaxes. So to begin the transaction, that is nothing but starting the transaction. So you can write like begin transaction. And this is one transaction, delete from students where fees equals to 40,000. So this is one transaction I am going to perform actually. So delete from students. Students is a table name, and I am going to delete the students who are whose fees is 40,000. Whose fees is 40,000. So after performing this operation, I am going to commit this transaction. I am going to commit this transaction. So after committing this transaction, I want to roll back this transaction actually. I want to roll back this transaction. So how can I roll back it? So as usual, you can begin the transaction. So what is the transaction you are applied actually? So I can write the transaction delete from students where fees equals to 40,000. Where fees equals to what? 40,000 and roll back. Now what is the result? You will roll back the transaction which perform the operation on delete on the table of students. So now you can retrieve the values of student fees whose fees is 40,000. And the next one, begin transaction. So save points applying. So to apply the save points, you can start to write like begin transaction. And for the save point SP1, so I am creating a save point for at the stage of delete from students where ID equals to 1. So whoever having the ID equals to 1, I am deleting all the students. And for the second point, for the save point second 2, I am deleting the students where ID equals to 2. Similarly, I am going to create a save point 3 for deleting the students where ID equals to 3. So after creating all these save points, I am going to roll back or restore or recover the data whose ID equals to 2 who is deleted from the student table. So that what should I do? I do just roll back to SP2. I do just roll back to SP2, so that only this particular operation is only this particular transaction is rollback. So by creating all the save points, you can roll back if any of the particular point of transaction. So if you want to roll back for the save point 1, which is having id equals to 1, then you can roll back. Or which is having id equals to 2, then it is rollback. Where it is having id equals to 3, it is also rollback. So this is the way you can create the save points and roll back your SP2. So this is all about the transactional commands. So these are all the different types of transactional operations actually. So in this session we discussed about the transaction management actually. So what is meant by transaction, and what actually transaction started, what actually transaction used. So these are the transaction operations. And for the transactional operations, read or write, or read or access the data, write or change the data. So these are all some operations we do for transactions. And what are the uses of transaction management, and what are the different states, what are the different states of transaction management, and what are the different types of states: active states, probable state, and partially committed states, failed states, and all these types of states we are having. And transaction properties, so atomicity property, consistency property, and isolation property, and durability property. So all these properties were explained. And transaction control commands. So in the real time, in the all the different types of transactional operations are committed with these operations. The one is commit operation, second one is rollback operation, and the save point operation, and the set transaction operation. Set transaction is nothing but you can write the name for the transaction actually. So by writing the name, by mentioning the transaction type, set transaction, so you can easily find out the transaction which is failure, and you can roll back it very easy. You can roll back it very easy. And so how we are writing the syntaxes for committing the operations, and rollbacking the operations, and the save points, and all. So this is the way you can create the save points. And after creating all the save points also, you can roll back any one of the transaction. Among these all the transactions, you can recover any of the transaction. This is about transaction management. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.